Okay, welcome back. This is Mr. Hassan's Maths channel. I'm now going to answer question number 9 from the January 2024 International A-Level Edexcel Pure Mathematics P3 paper. And this question here is about trig equations and identities. Now, part A says, show that the equation 3 sine theta cosine theta over cosine theta plus sine theta equals 2 plus secant 2 theta times cosine theta minus sine theta can be written in this form. Okay, so this is not an identity here. It's not like this side has to be written exactly like that side. This is an equation. So don't get fooled by that. I think a lot of students, they mix up with these type of questions. It's not saying show that this can be written in this form. No, it's saying show the whole of this equation can be rewritten in this form. So it's not saying that this side and that side are identical. All right, so don't start trying to make this side look like that side. Start with one side and make, no, it's nothing like that. This is an equation, non-identity, okay? And we have to show that you can rewrite the equation and make it look like this. Okay, so that's the first thing. So don't start wasting time doing things which in the end you will regret, because in an exam you will lose time. So be very careful when you read the question. Is it an identity or is it an equation that you're trying to solve? Okay, or we're trying to write it in a form that then obviously part B is where you have to try to solve the equation. So now we're going to try to rearrange this equation in such a way that you end up with something like this. Okay, now we can see, the main thing I can see here is that we have these single angles. The whole of this, all single angles here except for this one here, okay, have become double angles. Okay, there's a double angle there, but the rest of them have become double angles. So we got to think about the double angle formulae really for us to be able to sort this out. Okay, so in our mind should be the formulae, the sine of 2a equals 2 times the sine a times the cosine of a. Now if you haven't memorized them, it is a good idea to do so. And the cosine of 2a is cosine squared a minus sine squared a. You can also write it in terms of just cosine squared theta, or 2 cosine squared a minus 1, or you can write it in terms of just sine squared a, so 1 minus 2 sine squared a. So these are different ways of writing cosine 2a. That's a different way of writing sine 2a. Okay, so we got to try to go from single angles to double angles. That's what we have to try and do in this question. So the first thing I see is this 3 cosine theta, 3 sine theta cosine theta. Okay, it's kind of like linked to this. I want to make this into a double angle, right? So if you look at the pattern for this, okay, if you look how this became that, the angle has, the sine a cosine a became sine 2a. Okay, so the sine theta cosine 2 theta becomes sine 2 theta. So I'll write sine 2 theta. And the 1 here, the 2 here became a 1. The 2 here became a 1. So this coefficient, when it went this way, was halved. Okay, when you want to convert from this form to that form, this coefficient 2 became 1. Right, so this 3 is going to become 3 over 2. Okay, so I've now converted this into the form of a double angle. Okay, so that's definitely going to be one of the steps that we should take that will help us. And then we have over cosine theta sine theta plus sine theta equals, so I'm going to multiply both sides by cosine theta plus sine theta. So I have 2 plus secant of 2 theta. Well, that seems okay because it's already in double angle. Times, and you got cosine theta minus sine theta times this bracket cosine theta plus sine theta. Okay, so this is a double angle. How do I make these into double angles? Let's think about trying to. In fact, what I can do is I can multiply by the 2 as well. I can multiply by the 2 as well, so I end up with no fraction. So I'm going to put 2 here as well. Okay, so I'm multiplying by this 2 as well, so I end up with this. So now, in fact, I'll do it in 2 steps. One step at a time. Okay, so now I'm going to multiply by the 2, so I have 3 times sine of 2 theta equals 2 times 2 plus secant 2 theta. And these two brackets, I will actually expand them because I can see it's going to give me something that will help me. Cosine, this is a difference of squares. If I expand the bracket, I'm going to get cosine squared theta minus sine squared theta, because you have a difference of squares. So this is cosine squared theta plus sine theta cosine theta minus sine theta cosine theta, which disappears, and then minus sine squared theta. Now we can see this links into what we wrote up there. I can replace that cosine squared theta minus sine squared theta with cosine of 2 theta. Okay, so I have 3 sine 2 theta equals 2 times 2 plus secant 2 theta times the cosine of 2 theta. So now all my angles are double angles, and hopefully if I just expand the brackets here, everything will fall into place. So this is 3 sine 2 theta, which is what I need to have that there. This is going to give me 4, and 2 times 2 secant 2 theta. Okay, and then I'm going to have, that's going to be multiplied by cosine of 2 theta. Right, so I've just expanded that bracket. Okay, now I can, in fact, I can just do this in one step. Let me just do it a bit neater. So that 2 times the cosine 2 theta gives me 2 cosine 2 theta. I'll just do it step by step. Okay, so now we have 3 sine of 2 theta equals, that's going to give me 4 cosine of 2 theta plus 2 cosine 2 theta secant 2 theta. Now, you can see it's looking promising so far. We have a 3 sine 2 theta, we have a 4 cosine 2 theta. But what we should remember here is secant of 2 theta is 1 over cosine 2 theta. So that will just cancel out basically. I'll just show it, I'll write it out so that everyone's clear on that. This is 3 cosine 2 theta equals 4 cosine 2 theta plus, and you're going to have 2 cosine 2 theta over cosine 2 theta, because secant theta is 1 over cosine theta. They cancel out. So we're left now with 3 sine of 2 theta minus 4 cosine of 2 theta equals 2. Just subtract that from both sides, and that's exactly what we had to show. 3 sine 2 theta minus 4 cosine 2 theta equals 2. All right, so there's using the double angle formula here to get your answer. All right, so you should know how to switch between these. You should know these double angle formulae. Very important that you understand them and know how to use them. Okay, so there's the answer to part A of question number 9. Now for part B, it says hence, so we have to use the answers from the previous part of the question. Solve for x between theta and 3 pi over 2. Of course, in radian mode, that means this equation. So I can just straight away, using part A, rewrite this equation. It's just the theta now is an x, that's all. Theta is an x now. So I'm going to write this as this equation here, but just change the theta for x. So you can say, because of part A, you end up with 3 sine of 2x minus 4 cosine of 2x equals 2. So I have to solve this equation. Okay, now, this is the type of equation where it's difficult for you to make them into the same ratio. And this is one of those equations, and one of those places where there's a skill which has not really been asked about. I don't think in the last exam it was on. It's a few P3 exams I haven't seen it, maybe if my memory serves me correctly. So this is something that we should remember, and they didn't tell us here to use this particular thing. There could be other ways of doing it, but the most kind of the way that comes to my mind is when you have this, r sine or r cosine, x plus alpha, this kind of thing, when you have to set it up in that particular way. That's what comes to my mind when I see something like this. And when I have a sine and then I have a cosine and there's a minus between them, then I'm thinking of r of sine. In this case, it will be 2x minus alpha. So I'm going to write this in this form. Okay, 3 sine 2x minus 4 cosine 2x. I want to write it in this form. And then it will be something that I can solve. Then I can divide by r and I can solve the equation. All right. So that's what I'm going to look at, because I know that if you look at the double angle formula, you have sine of A minus B will give you sine of A cosine of B minus cosine of A sine of B. So you'll end up with sine and cosine minus between them. If you use this form, it will be kind of compatible with this. So I'm going to rewrite. Okay, so first step, I'm going to take 3 sine of 2x minus 4 cosine of 2x, and I'm going to write in the form r of sine of 2x minus alpha. Okay, that's what I'm going to do. Okay, and normally in these type of questions, they say write this in that form. In this question, they didn't tell us. And there are some alternative methods also to solve this equation, which I will go through, hopefully at the end of the video. We'll see how I feel. Anyway, let's just sort this out now. So we have 3 sine 2x minus 4 cosine 2x equals, it was identical to r times. Now I'm going to use the addition formula to expand this. This is going to be r times sine of 2x cosine of alpha minus cos r times, because you are multiplying both of them, cosine of 2x sine of alpha. Now what I'm going to do is I'm going to compare the coefficients of sine of 2x and cosine of 2x on both sides of this identity. So I got sine 2x here and sine 2x here, and I have cosine 2x here, I have cosine 2x here. So if I compare, let me start with the cosine 2x's. Let me compare the cosine 2x. On this side, I'm going to have 4. I'm going to ignore the minus sign because they're both minus. Right? So on this side, I have 4. On this side, I have r sine alpha. Okay. And if I compare the sine 2x's, okay, so I first compared the cosine 2x's. Now I'm going to compare the sine 2x's. So if I compare the sine 2x's, I'm going to have 3 on this side, and here I'm going to have r cosine alpha. Now there's 2 ways we can proceed now to find alpha and r. Now one of the ways is to rewrite this as sine of alpha equals 4 over r, and here cosine of alpha equals 3 over r. And we can make a sketch of a right angle triangle. Okay, so you make a sketch of a right angle triangle. Okay, and it doesn't have to be accurate at all. Okay, it doesn't have to be accurate. Just any old right angle triangle will do for now. Okay, so we have here a right angle triangle. Okay, a sketch of something that's supposed to be a right angle triangle, let's say. Okay, I haven't drawn it very well, have I? Okay, now, so you have the right angle, you have alpha. We know the sine of alpha is opposite over hypotenuse, so that's 4, and that's r. And the cosine of alpha is adjacent over hypotenuse, that's 3, and that's r. So we can find r by Pythagoras theorem. It's going to be 5, 3, 4, 5. R is going to be 3 squared plus 4 squared under the square root. So r is equal to 5. So we know what r is. And we can find alpha just saying, for example, we can say the tangent of alpha is equal to opposite over adjacent, 4 over 3. So alpha is equal to inverse tan of 4 over 3. So we can do that. Inverse tan. Now we should be in radian mode. We should be in radian mode. Are we in radian mode? Yes, we are. So we say inverse tan of 4 over 3. Okay, so that's going to give us 0. So alpha is 0.92729. Alpha is 0.9. Remember, like I said here, 27295. 27295. They want it to 3 significant figures. So alpha is equal to 0.927. Okay, so now what we can do is, sorry, that's the final answer. What am I doing? 9272. We'll leave it like that for now, and we can round it at the end, our final answer. So now what I can say is I know the value of r. So I know that 3 sine of 2x minus 4 cosine of 2x is identical to 5 times the sine of 2x minus 0.9272. Okay, so I know that this is true. Now we can use this to solve the equation. So therefore, if I want to solve 3 sine of 2x minus 4 cosine of 2x is equal to 2, which is the original equation we asked to solve here, then we can just simply replace this by 5 times the sine of 2x minus 0.9272 equals 2, and I can solve this equation. Now this is an equation that we can solve. Divide both sides by 5, so we have sine of 2x minus 0.9272 equals 2 over 5. Now let's look at the limits that we have. The limits are between pi and 3 pi over 2. So we have x is between pi and 3 pi over 2. And we're solving for 2x minus 0.9272. So our limits have to be adjusted accordingly to this. So I have to take the x multiplied by 2. So I have to take the pi multiplied by 2 and take away 0.9272. So this answer that I have here, I'm going to store this as a, right? Because I'm going to need it for this. So I'm going to do 2 times pi, 2 pi minus 0.92, okay, 72. And here I'm going to have 2 times 3 pi over 2. So multiply this by 2 and then take away 0.9272. So I'm going to work out what the limits are now. So I've got 2 pi minus the answer. That's going to give me 5.3558. So my limit here is 5.3558. 5.35589. 0.35589. And this is your 2x minus 0.9272. And on this side, we're going to have these cancel out. So we're going to have 3 pi minus the answer. 3 pi minus the answer, because those 2's cancel out. And that's going to give me 4 point... Hold on. What was the last one? Hold on. No, not minus the answer. My bad. Minus a. Not the last answer. Be careful there. Minus a. Of course, it has to be bigger than that. So it's 8.4974. So be careful about using answers. It has to be the last answer. So that's why I've gone back to this. So it's 8.4974. 8.4974. 4974. So I've just written it to a few more decimal places for accuracy's sake. So now I have to, my limits of my angles are between these two limits. Okay, I have to catch angles between those limits for 2x minus 0.9272. When I've found my answer, I have to adjust for x. So the first answer, so I have 2x minus 0.9272 is going to be given by inverse sine of 2/5. Okay, inverse sine of 2/5, giving the answer. And you can see here there's going to be one answer, right? Not multiple answers. Okay, because it's a very limited range, you see. So if I find the inverse sine of 2/5, so inverse sine of 2 over 5 in radians, that gives me 0.411516. 0.411516. So write it always to more decimal places than you need. Now, is that within our range? No, it's not. It's not in our range. However, how do we find angles in our range? We take this angle and we subtract it from 180. That's the other angle in the range. Okay, this angle is not in our range because we have to start from 5.355 and end at 8.497. So I'm going to do pi minus this angle to give me the other angle in the range. Okay, for this. So we're going to take this and we're going to do pi minus the answer. So pi minus the answer, which gives us 2.73. That's still not in the range. Okay, so 2.73007. 2.73007. Okay, yeah. So that's still not in the range. So now what do we do? To get the other angles in the range, I add 2 pi. So I'm going to add 2 pi to this. Okay, if I add 2 pi to this, so I'll take the last angle that I got, which was this, and I'll add 2 pi to it. Now that gives me 6.69, and that's in the range. So I'm going to take this angle here and have 0.411516. I'm going to add to it 2 pi. Okay, so you end up with 2x minus 0.9272 equals, and if you add 2 pi to it, you get 6.6947. 6.6947. How many? We want 3SF in the end, right? Okay, so we can leave it to more than 3SF. That's fine. So that's going to give us our answer now. The only answer. If I add 2 pi to this, it's going to be outside of our range. Okay, we can try it if you want, but let's just keep this answer in our calculator for now. So 2x is going to be 6.6947 plus 0.922. Okay, and we can just do that divided by 2. And that will give me my value of the angle x. So I've got this plus 0.9272. Okay, and then divided by 2. That gives me 3.81095. 3.81095. Okay, so therefore x equals to 3SF, 3.81 radians. That's the value of x. Okay, that's the value of x, and that answers this question. All right, so it's a bit involved at the end, working out what angle to choose. You just have to keep your wits about you, right? You have to understand that our limits are determined by this, and you know the first 2 solutions we get are outside of the range. They're outside of the range. You have to start from 5.35, and you know the first solution, which gives the calculator gives us, is too small. 180 minus that, or pi minus that, again is too small. But then if I add 2 pi to this, it will be in the range. And you see, if I take this answer here, which was this answer here, so I'll do pi this. If I'll do pi minus this answer, yeah, pi minus the answer that we got, yeah, this. If we take this and we multiply, if we add 2 pi to it, okay, then see that's outside our range. Okay, so it's only adding 2 pi to the answer we got from this one. Okay, where was it gone again? Yeah, adding 2 pi. Let me write it neater here. So we took this angle here, 0.411516, and we added 2 pi to it. Okay, that gives you the other answer. So basically, for the sine curve, okay, if we take this as an angle, we have something like this. Okay, so this gave us an answer here, which is out of our, which is too small. Then we got this answer here, which is too small. We took this angle and we went all the way over there, basically, and that was the angle that we needed. Okay, so there's the answer to this question. I hope that was clear, right? It takes a good understanding of trigonometry, of how to rewrite things in the right form. This must have been I think this was a key question for a lot of students, especially the last question. It's a bit nasty actually, but anyway, you know, they didn't tell you to put it in this form. There are other ways of answering this question, maybe by using, and I'm going to show you actually. I know it's going to be a long video, but I'll show you some other ways of answering this question. Okay, so let me just do that. Okay, now for alternative method of solving this problem, let's try to use let's try to rewrite this in terms of the double angle formula. So I know that sine of 2x is the same as 2 sine x cosine x. And I know that the cosine of 2x is equal to, let's write it as cosine squared x minus sine squared x for now. So this will be 3 times 2 sine x cosine x minus 4 times cosine squared x minus sine squared x equals 2. All right, so that gives us 6 sine x cosine x. Okay, now what I'll do is that'll be minus 4 cosine squared x plus 4 sine squared x equals 2. Yeah, at this stage, and this can be a bit of a palaver here, and I wouldn't do it this way myself, to be honest, but we could, at this stage, we could try to get rid of and change things in terms of tans. Like if I divided everything by cosine squared x, not to get rid of any factors or anything like here, like it's not like there's no factors of cosine x here at all, but in order to use the identity that the tan of x is sine of x over cosine of x, if I did that, what will happen here, I have 6 sine x cosine x divided by cosine squared x minus 4 cosine squared x divided by cosine squared x plus 4 sine squared x divided by cosine squared x equals 2 divided by cosine squared x. Now what happens is one of the cosine x's will be cancelled out and I'll be left with 6 times tan x minus those both will be cancelled out. I've got minus 4 and this will give me plus 4 tan squared x equals, and that's going to be secant 2 secant squared x. Now why is that going to help us? Because I know there's an identity for secant squared x. I know that sine squared x plus cosine squared x equals 1 divided by cosine squared x gives you tan squared x plus 1 equals secant squared x. So I can replace the secant squared x with tan squared x plus 1. So here I'm going to have everything in terms of tans. I'll have 6 tan x minus 4 plus 4 tan squared x equals 2 times tan squared x plus 1. So if I expand the bracket there, I have 6 tan x minus 4 plus 4 tan squared x equals 2 tan squared x plus 2. Now I can make a quadratic out of this. I can bring everything to one side. So I have 4 tan squared x minus 2 tan squared x, which is 2 tan squared x. I have plus 6 tan x. I have minus 4 minus 2, which is minus 6, equals 0. So now I have a disguised quadratic equation, which I can now try to solve. I can divide everything by 2. So I have tan squared x plus 3 tan x minus 3 equals 0. I can say let u equal tan x, in which case I'll have u squared plus 3u minus 3 equals 0. Now I don't think there's any numbers that multiply to give me this, so I can use the quadratic formula. I don't think this factorizes at all. So I can say minus b, which is minus 3, plus or minus the square root of b squared, which is going to be 9 minus 4 times 1 times minus 3, all over 2 times 1. So u is going to be equal to, let's have a look. You have minus 3 plus the square root of 9 plus 12, right? Divided by 2. So you end up with minus 3 plus root 21 over 2 plus or minus root 21 over 2. Now, if I do minus 3 minus root 21 over 2, it's going to be, of course, no solution. So the only solution we're going to get from this is when tan of x is equal to minus 3 plus root 21 over 2. So x is going to be, so it's this, inverse tan answer equals. So you got x equals 0.669 40. 0.66940. Okay, and that's not in our range. That's not in our range. Okay, our range is from pi to 3 pi over 2. I hesitate there a bit because it wasn't the right answer, but we forgot something there. Remember, it's not in our range. Okay, our range is from pi, which is 3.142, okay, up to 3 pi over 2, which is, 3 times pi divided by 2, which gives us 4.712. 4.712. So I'm going to take this answer, okay, and for tan it's easy, just add pi to it. So if I add pi, if I take the answer 0.66940 and I add pi to it, is that going to be in the range? Yes, it is. Okay, so I'm going to take the answer that we had over here, inverse tan of this. Okay, I'm going to add pi to it, and that's going to give me 3.81. That's exactly the same answer, is it? Is that the answer that we got? Oh, yes, it is. Good. So it worked out in the end. Okay, so you end up with x equals 3.81 099 dot dot dot. So x equals 3.81. So that's other solutions will be out of the range. If I add another pi, of course it's going to be outside of the range because it's going to be, add another 3 points, it's going to be outside of this range here. Okay, so that's the second way of answering it. I think this is very complicated, to be honest. All right, very difficult, especially when you get here. It's like, what do you do next? It's a bit difficult to see that you need to divide by cosine squared x, but it gives you the same answer. There are also other ways of doing it as well, by, for example, squaring both sides of this equation and ending up with things in terms of sine squared 2x and cosine squared 2x, but that's even more complicated. So I'm not going to bother going through that other method. Personally, I think this method is the easiest. So if you see something like this that you have to solve, like, you have the sine and cosines of the same angle, 2x, 2x, for example, x or x, whatever, and they're equal to, if they're equal to 0, it's no problem. You can then divide by cosine x to make it into tangent and you can proceed. But it's equal to another number like this. You can use this form to rewrite it into a form that is easy for us to then solve. So this is something that didn't come up for a few papers, and here it came up in a kind of hidden way, because normally they will say write this in this form, therefore solve this equation, but they kind of like sneaked it on you in this last part of this question. So anyway, that's the end of this question. I hope that was clear. Other questions from this paper, which we have now finished, can be found in the playlist that will appear in the top right of this screen at the end of the video. Other questions from the topic of trig identities and equations can be found in this particular playlist over here. I'll have these R-type questions as a special playlist for those over here. You can subscribe to my channel by clicking on this link. Thank you for watching. I hope you understood everything. We finished the paper now, and it was beneficial. And see you soon.